Okay, so here we have equations of lines and slopes of lines. We're going to focus specifically on slope today. This whole unit is going to be about lines, and then in chapter 4 we'll step it up to start talking about triangles. So just to kind of start us off here with, well, where knowing stuff about lines might be helpful. We have a little story problem. You and a friend enjoy exercising together, and you're going to go running when your friend receives a phone call. You decide to start running and tell your friend to catch up after the call. The red line represents you, and the blue line represents your friend. Will your friend ever catch up? And so I hope you're looking at this and it looks like these two lines to you will never intersect. So I'm going to say no. Our friend will probably not ever catch up if he keeps going at that same rate. So what is your running pace speed? Well, it looks like you're going one block over and one block up. So that is 2. Each one of these is an increment of 2, and each one of these is an increment of a quarter, 0.25. So that would be 0.25 for the rise over 2 for the run, or in other words, 1/4 over 2 over 1, which we know to divide fractions. You flip and invert, you multiply. So your running speed is 1/8 of a mile per each 1 minute. What is your friend's pace? Well, since my friend also went over 1 block and up 1 block, it would also be 1/8. How does your pace and your friend's pace help explain why your friend will never catch up? Well, I hope you're thinking to yourself, if we started at 2 different times, of course he'll never catch up if we're going the same pace. He would have to run faster in order to catch me. So we have the same rate or pace or slope, whatever you want to call that. Therefore, the lines will not intersect. Therefore, will not intersect. They will not cross. He will never catch you, in other words. Okay, so this is a great example of an algebra problem, actually, where you had two lines that won't intersect, and we'll talk about here in just a minute that that's going to be called parallel. The lines are parallel. So just a quick reminder here, what we've been talking about, this rate, this pace, this slope, was indeed what we call slope. I have here all the different kinds, not all, but a lot of examples of positive slope here. And I'm wondering if you remember, if these are all lines with different slope, what exactly slope is. How would you describe what's changing here? Some of my classes say the angle is changing, Miss Benton, and that is definitely a trigonometry or physics way of thinking of it. It is definitely the angle here is getting steeper. But we're just going to not even talk about the angle yet, since we're not ready for trig yet, and we'll just say it's just the steepness of the line. It's how steep it is or how flat it is. The bigger the fraction, the steeper the slope. And we see that that's true over here. We have a slope of 6/7 versus a slope of 1/7 or of 0. The smaller fraction, the flatter or the less steep. Okay, and we know that on the grid we can do rise over run to find the slope of something. We know if we have points, coordinates, that we can use the slope formula to find rise over run, to find the slope, the steepness of the line. All right, so here's our first example. Determine which line passing through the points has a steeper slope. So we have line 1, and then we'll come over here and do line 2. Okay, so line 1 versus line 2. Here we go. Line 1, we can use the slope formula, y2 minus y1 over x2 minus x1 to find the slope of line 1. I'm going to label my points x1, y1, x2, y2 to plug into the formula. 2 minus the negative 4 over 2 minus 0. So that's going to make it 6 over 2 or 3 over 1. Then for line 2, let's see her slope. Same slope formula we know we can use with ordered pairs with coordinates. This would be part of coordinate geometry, by the way. That was on our review packet the other day. 5 minus the negative 4 over 4 minus 0 would be 9/4. Or as a proper fraction, 4 goes into 9 2 times with 1 left over, so it'd be 2 1/4. All right, so who has the steeper slope? How do we know? I didn't graph it. Is there a way to tell without graphing it? Well, we said back on the first page, the one with the bigger fraction is steeper. So which one is the bigger number? 3 over 1, or 3 would be bigger than 2 1/4. So line 1 is steeper. Okay, let's talk about parallel and perpendicular lines. Okay, so these are super important in geometry. We're going to use them with shapes, but also just thinking in terms of, if you want to build a road, you're going to build a road with parallel lines, right? You don't want to build one with wonky lines. Also, so construction, architecture uses a lot of, engineering uses a lot of parallel lines. We also, in art, see a lot of parallel lines and perpendicular lines. So those are a couple places where they come in handy in the real world. So parallel lines are lines that never intersect. They never cross. They're lines going in the same direction. They're lines that have the same, I hope you remember, that they have the same slope. So here we have 2 parallel lines. Whoa. Okay, and just a little reminder here that all vertical lines are going to be parallel to each other. That just makes sense. They're both going straight up, and as well as all horizontal lines would be parallel to each other. Okay, that's parallel lines. Let's look at perpendicular lines. These are lines, you might recall, that cross at right angles, 90-degree angles. They're lines that have opposite reciprocal slopes. Okay, so there's a 90-degree angle, or right angle right there, and these have opposite reciprocal slopes. So for example, 2/3, reciprocal means flip. Opposite means the sign is opposite. Instead of positive, it's negative. So over here, we would expect to see 3 over 2 instead of 2 over 3, and this one's positive, so that one's negative. They're opposite reciprocals. A lot of times, instead of people saying that they're opposite reciprocals, we'll say that they have slopes that multiply to -1. So if you think about it, and we kind of did this back in the last chapter, we had conjecture about this. 2/3 times -3/2. We have 2 times -3 is -6. 3 times 2 is 6. Oh, looky there. It is indeed -1. And that will always be the case with opposite reciprocal slopes. So sometimes people say instead of they have opposite reciprocal slopes, the product of their slopes is -1. So here again we have 4 over 1, -1 over 4. And just a reminder, 0 and undefined are considered opposite reciprocal slopes. Okay, last thing about perpendicular lines, all vertical lines are perpendicular to all horizontal lines. And we see a picture of that here. Okay, last example, and then we'll call it good. Determine whether P, Q, and UV are parallel if they have the same slope. They're perpendicular, they have opposite reciprocal slope, or neither. Okay, so we know PQ, to find her slope, we're going to use points P and Q for UV, it makes sense that we would use points, U and V. Okay, so let's come down here and find the slope of PQ. We're going to say 1 minus the negative 2 over 9 minus the negative 3. I'm just using the slope formula here, friends. So that's 3 over 12, or in other words, 1/4. And now let's do the same thing for UV. So that's negative 2 minus 6 over 5 minus 3. So that's negative 8 over 2, or negative 4. So we have negative 4 to compare with positive 1/4. Are those the same slope, opposite reciprocal slope, or neither? It looks to me like those are indeed the flip of one another. They are the opposite reciprocal slopes. Therefore, or we'll just draw an arrow. Okay, therefore, these guys have to be perpendicular. Okay, so you might want to pause the video here and do the U-try, and we can come back and check and see how you did. Okay, so here I found the slope of PQ was 7/8, the slope of UV was 7/8, and so since they have the same slope, they are parallel this time. Okay, so here you have down at the bottom your homework. I will say don't graph those three. And I'll see you next class, ready to pick up on lines. Thank you very much.